Hi guys, it's Miss Bentley, and today is going to be our second lesson of new content. We started Unit 3, and yesterday you looked at tables and identified whether or not the data represented linear functions or exponential functions. So remember, with an exponential function, it's going to increase much faster or decrease fast rapidly. So you're going to see a multiplying pattern. We call that a common ratio. And today we're going to start to actually look at some of the graphs. We're going to dig more into that equation, and we're going to start to write simple exponential functions. So I'm going to share my screen. This is a Desmos activity. You'll also, after I explain the lesson, you will need to log into the Desmos activity, and you'll be able to skip ahead through the instructional slides, but there are a couple questions at the end that I need you to practice writing the linear functions. And there's one slide where you're going to actually match and sort the graphs and the equations into exponential growth versus exponential decay. So just listen carefully as I explain these first few slides, and then you should be able to successfully do that matching activity. Okay, so the first thing is, what is an exponential function? So an exponential function is a mathematical function, and it's following the form f of x equals a times b raised to the x power. So notice x is a variable, and it's also our exponent. So that's why this is called an exponential function. A in the equation, so right here in the equation, I've also included a picture here. The A is always going to be your initial starting value. So on a graph, that's going to be your y-intercept. B, this is going to be your growth or decay factor. So what I mean by that, there's some restrictions here for us. So it says if B is greater than 1, so if this B value is a number larger than 1, then we know our function is increasing. We also sometimes refer to that as growth or growing. Okay, if your B value is between 0 and 1, so if it's like 1/2 or 0.5 or 0.4, numbers that's between 0 and 1, then that's going to be an exponential decay or decreasing function. So you need to recognize just by looking at the equation whether or not the equation is increasing or decreasing. Some restrictions we have with exponential functions is A should not equal 0. And then B needs to be a number greater than 0. So B has to be, it can't equal 0. It's going to have to at least be 0.1, but any number greater than 0, and then B is never going to equal 1, because when we multiply times 1, that does not change the value. Okay, so we're going to look at the graph in just a moment on Desmos, and that'll start to all make more sense as we play around with some of the sliders. Okay, I'm going to go ahead and move forward to the next slide. So here it says, let's take a look at the graph of an exponential function. Use the sliders to explore the equation. Remember, A should be the y-intercept and the function, is increasing if B is greater than 1, and it's decreasing if B is between 0 and 1. Notice that when the function has a value, right here where B equals 1, we're just basically getting a horizontal line. So that is no longer a linear function. So let's just start with, okay, let's say our starting amount is 2. So as I slide my A value, as I slide it to 2, you'll see that the line now intersects the y-axis at 2. Again, that's the initial starting amount, also the y-intercept. As I increase the B value, remember B cannot equal 1. If B equals 1, it's just a linear function. But notice as soon as I increase our B value greater than 1, we start to see this curve. And this is what the exponential graph is going to look like. Now, the faster it increases, notice that it's getting steeper, okay? So it's increasing faster, so that graph is becoming narrower or getting steeper. So notice, it's only going to let you drag out to 10, but again, it's still not changing your y-intercept. Notice the graph is still starting at 2. It's just causing this curve to increase much faster. So this is the B value here is called your growth factor, because right now B is greater than 1. Now, if I drop the b value less than 0, or actually less than 1, that's when we're going to see decay. So notice now the graph changes directions. Now our graph is curving downward from left to right. So this is an example of exponential decay, or we could say this is a decreasing function. Again, as I move it, well, now I've gone into the negatives. You don't want to go into the negatives. The negatives are just going to take our function and reflect it over the x-axis. And you'll learn more about reflections next year in math too. But we're just wanting to stay right here between 0 and 1. Again, notice the y-intercept is still 2. So now when you look at an equation, if your b value is between 0 and 1, you should recognize that it's decay. And this a value is your y-intercept. Now I'm going to change that y-intercept. Notice I've dropped the y-intercept to 0.1. So now this line or curve is coming down and intersecting the y-axis at 0.1. If I increase the y-intercept to 4.5, then when I click on the y-axis, you should see that your y-intercept is at 4.5. Okay, so that's just a little place for you kind of to explore. This is called the parent function of an exponential, and you can change the values of a and b to see how that does affect your graph. Okay, so now let's explore a little bit more. So what I want you to do on this screen, I'm not going to answer this question for you. I just want, based on what we did on that last screen, tell me if this function is increasing or decreasing, and then identify the y-intercept. So you're going to do that with this graph. Then I think I have one more. Okay, and here's the second one. I'm giving you the graph of the equation y equals 2 times 0.5 to the x power. Again, what is the y-intercept, and is this function increasing or decreasing? So if you look, this is just going to recap the two types of graphs we've explored. This says the blue graph is decreasing and has an equation of 2 times 0.5. So notice the number that's in the parentheses is less than 1. That's an indicator that this is decay or it's decreasing. Notice that the blue line is going downhill from left to right. So I can look at this graph and determine that that is decreasing or decay. With the red graph, notice the equation has a b value of 2. 2 is greater than 1. So that is an increasing exponential function. And notice the red line or the red curve is going uphill from left to right. So the direction of the graph is going to easily tell us whether or not it's growing or decaying. And then in the equation, you're looking at the b values, that's 0.5 and the 2. Okay, on the next screen, this is where you're going to sort. So you would want to pull these titles up to the top. There's one that says exponential growth, an increasing function, exponential decay, or a decreasing function. And then you're going to start dragging the graphs and the equations just to wherever you feel like it belongs. And whenever you drag it, it's just going to clip right onto that. And it will show you have so many cards. At the end, I'm not sure if I have an answer key, so I'll make sure to come back and go over this tomorrow in tomorrow's lesson. But go ahead and match those up based on what we've learned on those first 5 screens. Okay, so now we're actually going to start writing equations, and we're just working with the simple ones today. So it says, let's take a look at writing simple exponential functions. Here's our first example. Suppose 30 rabbits are taken to an island. The population doubles every year. Write an exponential function to represent the situation. So remember, A is the starting amount, B is going to be either your growth or decay rate, and then X in this situation is going to be how many years this growth has been occurring. So an exponential function is y equals a times b to the x power. And we need a number for a, the starting amount, and for b, the growth or decay rate. So in this one, it says the population is doubling. So that means the population is increasing. So this should be exponential growth. The starting amount of rabbits right here is 30. And then it says it's doubling. So if we double something, we multiply by 2, so your growth rate is going to be a 2. So your exponential equation is y equals 30 times 2 to the x power. Now, I'm going to let you answer these the 2 questions. Is this equation growth or decay? I've actually already mentioned that. And then how many rabbits would be on the island in 5 years? So remember, x represents the number of years. So you're just going to substitute 5 in for your exponent and calculate 30 times 2 to the 5th power. And then just put your answer in this box and submit it, and then you're ready to move to the next screen. Okay, I'm going to do one more with you. Each year, the YMCA hosts a basketball tournament. There are 256 teams to start the tournament. During each round, half of the teams are eliminated. So remember, A is the starting amount. So in this scenario, that would be the 256 teams. So notice in my function where A would be, I've substituted in 256. B is your growth or decay rate. Well, they said after each round, half of the teams are eliminated. So our growth, or actually not growth, decay rate in this problem is 0.5. That's equivalent to 1/2. Or you could put 1/2 here, that's fine, 1/2 or 0.5. And then you would raise it to the x power. Now in this problem, x is representing the number of rounds. So now you're going to answer the 2 questions. It says, is this equation a growth or decay? And how many teams would remain after the 3rd round? So just put your 2 answers in this square or rectangle and then submit that. Okay, and then on the next, I think 3 screens, I'm just going to jump, actually 1, 2, 3, 4, 5, 6, 7 screens, you're going to answer a few questions. So you're going to write equations and then you're going to use your equations to answer a question. Okay, and then this last one is just something for you to think about. I'm giving you 2 options that your grandmother is willing to, how she's willing to give you money for your birthday. And I want you to pick which option you think would be the best. And then tomorrow when we come back together, we're going to talk about these 2 options and actually graph them and compare them. So answer option 1 or option 2, and then we'll learn more about those options tomorrow and see if you made the best choice. Okay, and then your assignment for this lesson is today you will need to complete the quizzes assignment on exponential functions, and tomorrow we'll take a closer look at the 2 birthday options. Again, guys, I hope you're staying healthy. I hope you're doing well. Continue to email me, send me messages through Reminder Canvas. I'm happy to help you with any of these assignments, but please reach out to me if you need some help. I'm going to stop sharing, and I'm actually done for the day. Real quick lesson. I'll also post, I'll still continue to post those resource videos on my school website. So if there's something you feel like you just didn't quite understand and you need a little bit of reinforcement, I'll also post those videos if you need additional help. But please, please, please email me specific questions you need me to work out or explain. And I don't mind jumping on and either making a quick video to send you, or I can try to answer it through email or through a quick text message on Remind. So good luck with everything. Stay safe, and I will see you guys on tomorrow's lesson.